While any commercial grower knows about the importance of monitoring and optimizing pH levels, electrical conductivity measurements are a lesser known but valuable tool for gaining awareness of the nutrient levels in your plant's growing medium. Electrical conductivity, EC, is a measurement of how well a fluid conducts electricity. A fluid with higher concentration of soluble salts is more conductive, and a lower concentration of soluble salts is less conductive. We've set up a device to show you how different liquids conduct different amounts of electricity. On both the positive and negative charge of the battery, we have connected cables. The red cable will conduct electrons from the negative charge of the battery. The green cable will pull those electrons through our media into the positive charge of the battery. This circular device produces sound when electrons are conducted. Distilled water has little to no soluble salts, so it does not conduct much electricity. You may not even be able to hear the faint beep we get from the measurement. A cup of our fertilizer will have lots of soluble salt, which produces a much louder sound. Now we compare a lower concentration of soluble salts to a higher concentration in our soil. The EC measurement reflects how much total soluble salt is available in the substrate. While the EC is nonspecific about which soluble salts are available in the growing medium, a few primary nutrients are usually of concern to growers: nitrogen, phosphorus, magnesium, and potassium. By monitoring EC levels along with your regular pH monitoring, you can adjust your fertilizer program to account for low or high soluble salt concentration to be sure your plants are receiving necessary nutrients without over-fertilizing. The EC measurement must be performed on liquid, so the goal is to extract water from the pots for testing that contains representative nutrient content for the growing medium. This liquid that you'll drain from containers in the PourThru EC method is called leachate. If you use careful procedure and attention to detail, the PourThru method is excellent for cheap, on-site continuous monitoring. For this process, you will need saucers, distilled water, plants to test, labels, a beaker with measurements, or a measuring cup, and an EC probe which can be bought on Amazon for about $20 or less. Follow these simple steps to remove leachate from the substrate for EC and pH testing. For every 1,000 plants, you will want to test 5 plants. Subsequent tests should be completed on the same plants used in the first test. It's helpful to label any pots used for testing to make record keeping easier. Use your regular irrigation method if you use a constant liquid feed program. If you do a period fertilizing program, irrigate with clear water a couple of days before your next scheduled feeding. Be sure to fully saturate the substrate. Allow containers to sit for 1 hour. This gives adequate time for the plant root uptake and substrate nutrient concentration to reach equilibrium and will give you the most accurate EC and pH readings. Place a saucer under each container to collect the leachate. You can use cheap plastic saucers for this original collection. Make sure they're clean and sterile and don't have any holes in them. For bedding plant flats, test 1 cell pack per flat by separating the pack and putting it in the saucer. Pour the appropriate amount of distilled water on the surface of each container's soil to push the leachate through the bottom. You'll need to pour on enough water to get about 50 milliliters of leachate from the container for testing. This amount will vary by container size at approximately the values in Table 1. Be sure to use distilled water. Drinking water and hose water have additional salts and may contaminate your sample. One set of university instructions indicates that you should use the same fertilizer solution you normally use to perform this step in order to push the equilibrated content out of the container as leachate without diluting the concentration of nutrients in the media. However, most studies and university practices use distilled water. The most important factor is to be aware of what you're putting in the containers, which you can't do if you use typical drinking or hose water. Once the pots are draining, allow them to sit for 2 to 5 minutes and then begin checking the saucers for the appropriate amount of leachate. You need about 50 milliliters per container to get accurate readings when you test. Collect the leachate from your containers in beakers for easier storing and testing. Beakers will also allow you to precisely measure and record the amount of liquid you collect. That amount should be about the same every time for accuracy. Go ahead and combine liquid from various containers if they're growing the same plants in the same media with the same fertilizer and are part of the same phase of growth. If you have a large crop of one type of plant, sample about 5 containers per 1,000 for accurate testing. Sample at least 2 containers for each plant type of smaller crops. Be sure to separate and clearly label liquid collected from different plant species in different growth stages. Use your pen or probe to test the liquid. Be sure to calibrate it properly prior to testing. Keep a clear and detailed record of your EC levels. Record the plant type, growth stage, media type, the fertilizer program being used, the amount of leachate extracted, and the EC level. You can also include the pH level and any descriptive information about the state of the plant. For example, leaves yellowing, bushy, drooping, etc. Combination pH and EC meters are available, allowing you to monitor both levels. As you test weekly, this record will enable you to identify trends, make connections between fertilizer and nutrient levels, and improve your overall growing program. The target EC range for your containers will depend on what is growing in them. Different plants need different levels of soluble salts, just like different plants thrive with varying pH levels. When you explore charts and information to determine the target range for EC levels in your soil, be sure to look at the suggested range for the correct method of testing. The suggested ranges for various plants will depend on your testing method. Be as careful interpreting the data as you were collecting it.